Hello there, my name is Gregory, and we are talking about college algebra and solving quadratic and cubic equations. So we just talked about what to do if you can factor and using the zero factor property, but what happens if we can't factor or if it's in a different form? Check this one out. Notice on this one, the entire left side of the equation is squared. We can take advantage of that. If you're solving a quadratic equation and this entire part over here, the entire part, not just one term like we had here, but the entire thing is being squared, then you can actually take the square root of both sides of the equation, just like this. Now there's two things to keep in mind when you do this. First, you have to take the square root of the entire side of the equation. You can't just take the square root of one piece or one term. The second thing is, when we do this, on the left side, the square root cancels the square. So that's really nice. We just get 2x plus 4. But when we take the square root, we get two things that happen. We get positive or negative the square root of 20. Remember, this degree is going to be 2 of this equation. So that means we should get two answers. If you forget this plus or minus on the right-hand side when you do this, you're going to lose one of your answers, and that means you're only going to get half credit. So you have to remember that when you take the square root, you have to put in that plus or minus when you're done. Now, let's go ahead and simplify this square root. Let's think of a perfect square that goes into it. I know that 20 is 4 times 5, so we could break that up into the square root of 4 times the square root of 5, and the square root of 4 is 2. So this would be 2x plus 4 is equal to positive or negative 2 times the square root of 5. All right, we're getting there. Let's keep going. Let's go ahead now and we want to solve for x. That's the goal. So subtract 4 on both sides. So that means I have 2x is equal to negative 4 plus or minus 2 square roots of 5. So notice that I didn't want to mix in my 4 with the plus or minus. It's just negative 4 plus or minus 2 root 5. Let's rewrite that again up here. 2x is equal to negative 4 plus or minus 2 root 5. Finally, let's solve for x. So by dividing by 2, and remember, you got to divide everything by 2. So x is equal to negative 4 plus or minus 2 root 5 divided by 2. So hopefully if you remember from the complex numbers section, we can actually simplify this because all of these numbers are even. So let's go ahead and break it up a little bit. Let's break that up into x equals negative 4 over 2 plus or minus 2 root 5 over 2. And you see that that'll simplify nicely. Negative 4 divided by 2 is going to become negative 2 plus or minus, those 2's cancel, square root of 5. So it's kind of like an imaginary number, but it's a little different because there's no I. So x is equal to the negative 2 plus root 5, or x equals negative 2 minus root 5. If you want, you could throw that in your calculator and make decimal approximations of the answer, but we mathematicians like to put the exact answer if we can, so I would be very happy if you left it right there. If you didn't have a plus or minus here, you'd probably lose half credit because you forgot an answer. Let's try again. See if you can get this one over here. You should go ahead and pause the video, try to get it on your own following this procedure, and see if you can get it. So see if you can pause it. And hopefully you got the right answer. So let me go ahead and do it now. Once again, the entire left side is squared, which is different than something like this, where the best strategy is to factor. So we'll take the root of both sides. The square root cancels the square, and I get 3x minus 8. This time it's nice. I actually get the square root of 36 is 6, but don't forget that once again we need that positive or negative. So 3x minus 8 is equal to positive or negative 6. At this point, it might even be a good idea to break this into two equations. One equation would be 3x minus 8 equals 6, and the other equation would be 3x minus 8 equals negative 6. I'm going to go ahead and solve it as one equation, but it might be easier to solve it as two. We'll add 8 to both sides, which would give me 3x is equal to 8 plus or minus 6. and then divide by 3 like we did before. So x is equal to 8 plus or minus 6 divided by 3. So let's go ahead and calculate our two answers out of that. Our first answer would be 8 plus 6 equals 14 divided by 3. So our first answer would be x equals 4.66 repeating. Now let's find the other answer. It would be 8 minus 6 divided by 3, which would be 2/3, which would be x equals 0.66666 repeating. So those are your two answers. Remember, this is kind of two equations here. One equation is with the plus, the other one is with the minus. If you left your answer as 8 equals 8 plus or minus 6 over 3, I'd probably not like that. You could write x equals 14 over 3 and x equals 2/3. That would be good. But I don't think you should leave it like this if all the numbers are there. As I said, if that process kind of confuses you, you could rewrite it like this. 3x minus 8 equals 6, and 3x minus 8 equals negative 6, and then just solve those two equations separately to get the two answers. So whatever procedure you like and get right is the one you should use. So that's how to use a square root to solve this, if it's set up for that. You also know how to solve it by factoring, but what if both of those work? Well, luckily we have a beautiful formula called the quadratic formula, and it is something you should memorize, so I'm going to put a star by it. Once again, we need a 0 right here. If you have a polynomial, a quadratic I should say, with coefficients of a, b, and c, you can plug them into this formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In a separate video, I'll show you the proof of where this comes from. You have to use a process called completing the square to get this formula, but you can actually convert this, if you solve for x, into this. So if you're interested in that, I'll show you that in a separate video. But let's see, I have a little bit of time, so I think I can go ahead and show you the first example. So let's actually do this example first, because we're all ready to go on this one. Notice I have my polynomial here. It's in the right form. It's in standard form with the square term first, then x, then the number. Also notice that it equals 0. The reason I didn't want to show you this one first is because we have to move everything over first. So I'll show you that in the next part. But let's go ahead and plug all of these values into the quadratic formula. In this case, a equals 2, b equals negative 13, and c equals 5. And we can go ahead and just plug it in. So let's do that. X is equal to negative 13 plus or minus the square root of negative 13 squared minus 4 times a times c. All of that is divided by 2a. So that's how you would plug it in. You want to be very careful because notice it's negative b, and b itself was a negative number. So it's negative 13, which is going to turn that into positive 13. So after this, it's just cleaning it up with the order of operations. So just be very careful with your signs. Negative 13 squared, that would be positive 169 right there. 5 times 2 is 10, times 4 is 40. So this is 169 minus 40. So let's clean this up a little bit. X equals 13 plus or minus the square root of 169 minus 40 is 129. And this is all over 4. So just be really careful. Do this in multiple steps in order to get your answer. So this is actually it. If you wanted to write your answer like this, I would be happy with it. Remember, it represents two different numbers. 13 plus the square root of 129 divided by 4, and 13 minus the square root of 129 all over 4. Those are the two answers, which you can just write in one equation by putting the plus minus there. So that's how to use the quadratic formula. Really, the only way to make it harder is to put in extra negatives. I'll show you another example of this, and we'll keep going in part 3. See you there.